Hello everyone, welcome to another lecture. My name is Noah Scheinbaum. Today's topic is on Pythagorean theorem and the distance formula. So what is Pythagorean theorem? Well, Pythagorean theorem states that if you have two legs of a right triangle, A and B, you can find the hypotenuse by using the formula a squared plus b squared equals c squared. This is not the same thing as a plus b equals c. For example, 3 squared plus 4 squared equals 5 squared, because 9 plus 16 equals 25, but 3 plus 4 doesn't equal 5, it equals 7. This is because of polynomial operations. We'll get to that later. Okay, so why is this useful, and what sort of problems can it help us solve? Well, we have this right triangle here with legs 5 and 12, and we want to find the hypotenuse, which is labeled as c. So we could just use a direct application of the formula. If a squared plus b squared equals c squared, then 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. So c squared equals 25 plus 144, which is 169. Now taking the square root of both sides, we get that c is equal to 13. And that's it. Memorizing this formula, a squared plus b squared equals c squared, is one of the most important formulas for finding the distance between 2 points, or finding the hypotenuse of a right triangle. Okay, how about problem 2? Well, this time we're given a leg and we're given a hypotenuse, and we need to find a missing leg. Now, we can't use a squared plus b squared plus c squared in the exact same way that we did before, but we can still use the formula. Remember that c must always represent the hypotenuse. Okay, a squared plus b squared equals c squared. Let's say that 3 is a, it could also be b. It doesn't make any real difference. So 3 squared plus b squared, this missing side is b, equals 5 squared. 9 plus b squared equals 25. Subtracting 9 from both sides, we get that b squared equals 16 and b equals 4. So the length of the missing side is 4 meters. Okay, so this is great and all. We have problems involving triangles, but what about problems involving distance? Well, the distance formula is the change in x squared plus the change in y squared, and then take the square root of that, and that's the distance between any 2 points. Now, this may seem confusing at first, but this is a direct modification of the Pythagorean formula. So think of the changes in x and y as the 2 legs, and the distance as the hypotenuse. Here's a demonstration explaining how this works. So let's call the distance between j and k d. Okay, we want to find the distance between j and k. But since it's a slanted line rather than just going vertical or horizontal, we have to use the distance formula. But instead of using the distance formula exactly without knowing where it came from, let's try to set up a right triangle. So let's draw these lines here and here, and now that we see that this distance is the hypotenuse of the right triangle with legs 6 and 1. We can easily find that this is 6 because the change in x from 1 to 7 is 6, and the change in y from 2 to 3 is 1. So now that we have the legs of the triangle, given that a squared plus b squared equals c squared, we can find that c equals the square root of 37. If you want to write this out as a decimal, that's perfectly fine. If you don't want to, that's okay as well. But now that we know that c is the square root of 37, we know that the original distance is the square root of 37. Okay, perfect. So let's have a word problem now. At the center of a town, there's a large library. Noah is standing 2 miles west and 5 miles north of the library, while Pranav is standing 6 miles east and 10 miles south of the library. How far in miles is Noah from Pranav? Okay, so this is daunting at first. There's a lot of words, a lot of unnecessary detail that we probably don't need. But let's just think of this one step at a time. Just for a frame of reference, let's call the library 0, 0. Just make the library the origin, because our other distances and locations are based on where they are in relative to the library. And let's define the positive x-axis as going east and the positive y-axis as going north. So, if the library is at 0, 0, and Noah is 2 miles west and 5 miles north of the library, then I am standing at -2, 5. And if Pranav is standing 6 miles east and 10 miles south of the library, then he is standing at +6, -10. So, if we plot this on a graph, here's what we have. We have Pranav over at 6, -10. We have Noah over at -2, 5. The library here, this is irrelevant. But the library is there just for a frame of reference. Okay, now we can use the distance formula the same way we did in the demonstration to set up a right triangle and find the distance. So, by doing this, we find that this distance here is 8, this distance here is 15, and then by using Pythagorean formula, 8 squared plus 15 squared equals 64 plus 225 equals 289. So 289 equals c squared. Taking the square root of both sides, the square root of 289 equals 17. So the distance between Noah and Pranav is 17 miles. Okay, perfect. And that's all for today. So thank you so much for watching, and we look forward to seeing you at the next lecture. Have a great day, everyone.